Hey guys, in this video I'll be showing you how to solve LeetCode question 112, path sum. So for this question we're given a binary tree and a target sum, and all we have to do is return true if there is a path from the root to leaf where all of the numbers add up to our target sum. And a leaf is considered a node with no children. So in this example you can see the target sum is 22. And if you took this path from 5 to 4 to 11 to 2, adding all of these numbers would give you 22. So then say like our target sum was 20, this path would not be valid because, or the path from 5 to 4 to 11 would still not be valid because 11 is not a leaf. So it has to end on a leaf node. And so the best approach, I think, for this problem, or at least the simplest, is going to be to use depth first search, because that way we can just make it a recursive call, and we won't need to store any like extra sums that we need to do further calculations on. You can just kind of know the current value that you're on. So if you start at 5, we could say subtract 5 off of 22 and then just move on to here. Subtract 4 off of 22, move on to 11, and so on. And you don't have to store what the sum would be here and then what the sum would be here if you tried to do it in, say, like a breadth first search method. So to do this recursively, I think the best way to think about it is to just pretend like all you have to deal with is the root. So to start, if the root value, or if our root node was null, that would be a reason to return false. So if root is equal to null pointer, we'll return false. And then in the situation where the root has the value equal to our target sum, that's when we would return true. And again, we're just not worrying about any like children nodes yet. So if our root value is equal to target sum, then we would return true. But we're actually going to have to again check to make sure that if this is the case, it's also a leaf node. So we'll have to do and root left is null pointer, and same thing on the right side. So if this is a leaf node and we've reached our target sum, then we can return true. And if neither of those are the case, that means there are children nodes that need to be checked, and they need to be checked for the target sum, but minus the current value that we're on. So we can declare a new variable. I'll call it new target, and it's just going to be the target sum minus our current value at root. Okay, so then with this new variable, we can call this function recursively. So we're just going to call hasPathSum on root left and with new target. So this is going to check now the child node. So say we started at 5, it would go down to 4 and check the same conditions for 4 with our new target, which is the target sum with the first value subtracted off of it. And then we're also going to want to check the other side, the right side. it'll just be the same exact thing, and we're using an OR here because if either side has this condition to be true, then we'll return true. And that should be it for this function. So I'll submit this to make sure it works. And it does. So for the complexity of this algorithm, for time, we could be checking up to every node in the tree. So we can just say that this is O of n, where n would be the number of nodes in the tree that we're given. And then for space complexity, it's also going to be, actually we'll say this is O of m, or how about O of h? Because even though we are not storing any complicated data structures, we still have to store the call stack since we are calling this function from within itself. And that call stack is going to be, like it could be up to the height of the tree. So the height we'll note as h for the space complexity. And that should be it. So thank you guys for watching, and I hope this was helpful.